Hey guys, I'm videotaping from home and I've got kids all over the place that are playing because they are also quarantined just like I am as well. We all tested negative except for my wife who still has COVID. So just trying to deal with the situation and try to shuttle them off to areas of the house so that they can play quietly. But if you hear noises or screams or slams or I don't know, toys tearing or ripping, it's them. But let's go ahead and concentrate on this now. This is a section that is going to be focusing on the real core of chemistry, and it's dealing with moles. You might remember we did an experiment with sodium chloride. It was a white crystal. We put it in a test tube. We heated it. It began to bubble or melt and then bubble, and it was bubbling off all the oxygen. We were trying to determine what the substance was, and we did that through the chemical formula. And we did it because the concept of this section is things do not react on a gram to gram basis. They react on a mole to mole basis, or a molecule per molecule, or an atom per atom basis. Two atoms or two molecules have to come together. It doesn't matter how many grams of each that you have, it's a atom per atom or a molecule per molecule or on a mole per mole basis. So it's not the grams. However, we're going to be starting with grams of material, but we have to convert them into moles. This is just like Mole City, okay? Except instead of going from grams to liters or from liters to particles, we're just going to be going from grams to moles and from moles to grams. We're just kind of taking that one step to Mole City and then kind of coming back. So this is what we're going to be doing with this section. So this is section 12.2, and you'll notice I have grams, moles, moles to grams. This is the main concept. So substances react on a mole to mole level, not gram to gram. So if we have grams, we have to convert them into moles. So notice how my R is here. My R is representing what are called the reactants. If you remember, my reactants are my starting stuff. So draw a dotted line right here. And over here are going to be my products, capital P for products. So if I have grams of reactant, I can convert it to moles of reactant just using the molar mass. If I have moles of product, I can convert it to grams of product just using the molar mass. Something new though is, well, how do I convert from moles of reactant to moles of product? This actually was the previous section that we did. This was the mole ratio. So we have reactants here, we have products over here. So if I have 2 moles of hydrogen, it will produce 2 moles of water. If I have 1 mole of oxygen, it will produce 2 moles of water. So these numbers, or these coefficients, this is called the molar ratio. And that's what's used to do this portion of the work. So let's take a look at this first step. If I'm going from grams of reactant to moles of reactant, what do I use? This is going to be sort of a chart for you to take a look at for you to know, how do I solve this type of problem? So what do I use? If I'm going from grams to moles, I am simply going to be using the molar mass. And it's going to be the molar mass of the reactant. We'll have some practice problems on the other side of this, and we'll be able to see this. So if I have a number of grams, I can convert it to moles because I can look at the sum of the atomic masses, and I can use the molar mass of the reactant. Where do I find? This is the sum of the atomic masses. And these are found on the periodic table. For example, H2O. What's the mass of H2O? O weighs 16. Each H weighs 1, 16, 17, 18. The molar mass of water is 18. So if I have 36 grams, I can convert that to moles of water by using the molar mass, by adding the sum of the atomic masses. Again, we'll get some practice on this on the other side of the page. Now, if I'm converting from moles of reactant to moles of product, what do I use? This is called the molar ratio. And the molar ratio, again, is found when you're comparing the reactants, the moles of the reactants to the moles of products. So where do I find these things? I'm going to be using the coefficients. The coefficients in the chemical equation for whatever problem that I have. So now I have a third step, converting from moles of product to grams of product. Okay, going from moles to grams or grams to moles, this once again is, what do I use? This is the molar mass. But it's not the molar mass of the reactant, it's the molar mass of the product. How do I obtain the molar mass of the product? It's just like over here. It's the sum of the atomic masses. So these are the steps to convert from grams to moles to moles to grams. We have a chemical equation. We have a certain number of grams of reactant. How many moles is that reactant? It will produce how many moles of product, and then how many grams of product will we get from that as well. So it's the central theme of grams, moles, moles to grams. So let's go ahead and we're going to get some practice using this. You turn your page and go to this right here. So again, here we see grams, moles, moles to grams, and here we have an equation. And we need to first balance this equation. So we have two n's over here, we only have one n over here, so I need to put what right here? I need to put the number 2. That gives me my 2 nitrogens, but then also gives me how many hydrogens? That will give me 6. So 2 times what will give me 6, and it's going to be 3. So now this is the balanced reaction. This means that if I have 1 mole of nitrogen and 3 moles of hydrogen, it will create 2 moles of this substance here, which is ammonia gas. So now, knowing this, there are 3 possible problems. Okay, you can have a one-step problem where you're just going from moles to moles, moles of reactant to moles of product. Okay, so take a look. I'm going to have moles of reactant and moles of product. This is going to be using this step right here, going from moles of reactant to moles of product. So what I'm going to need to use in this problem is what's called the molar ratio. So I'm going to be looking at the coefficients in the equation. Okay, so how many moles of NH3 will be produced from 0.60 moles of nitrogen? So this is what I'm starting with. So I should go ahead and write this over here. 0.60 moles of nitrogen. Okay, so again, how many moles of ammonia, NH3, will be produced if I have this many? So here's the question. If I have 3 moles, 1 mole of this, I will have 2 moles of this. So for every 1 mole of this, I'm going to get 2 moles out. I'm actually going to be doubling it. You could probably see mathematically, some of you might be able to see the direction this is going. Again, if I have 1 mole of this, I'm going to have 2 moles of the ammonia, but I don't have 1 mole, I have 0.60 moles. So what I need to do is I need to use what's called the molar ratio, and this is how you set up for the molar ratio. I'm going to cancel my moles of nitrogen, or my moles of N2, and I want to convert to my moles of NH3. So I'm canceling my moles of N2, which is a reactant, and it's converting into the moles of NH3, which is a product. Now, what's the ratio of these things? Again, we're going to be looking at the coefficients. So if you're going from moles to moles, it's the molar ratio. You use the coefficients in the equation. What are the coefficients in the equation? So what's NH3? NH3 is 2. So I'm going to put a 2 there. what's the coefficient for N2? It's an invisible 1. So when I do this, those are going to cancel, and I multiply those together, and this will give me 1.2 moles of NH3. So again, if I start with one of these, I get double the amount. If I start with this, I'm going to end up with double the amount. 1.2 is double that of 0.60, and we used the molar ratio for that. So now we're going to go to a two-step problem. How many moles of ammonia will be produced from 5.4 grams of hydrogen? Okay, we're looking at moles of NH3. NH3 again is my product right here. But I'm starting with grams of hydrogen. Each little arrow is going to represent a step that I need. My prior problem only required one step using the molar ratio. This is going to require me to convert from grams to moles of my H2, then from moles to moles of product. So let's start with my 5.4 grams. Sorry, 5.4 grams, that's not, right, there we go, that should be there. So 5.4 grams of hydrogen. Okay, remember that we have to compare things on a mole per mole basis. So I first have to convert my grams into moles. Okay, so let's go ahead and do a fraction bar. I'm going to cancel my grams of hydrogen down at the bottom, and I'm going to be converting into moles of hydrogen. Okay, up here, this is called the molar ratio. But down here, this is simply the molar mass. How do I calculate the molar mass of hydrogen? Well, I'll go back to the first step. So if I'm going from grams to moles of reactant, I have to have the molar mass of the reactant. This is the sum of the atomic masses. So I'll be using the periodic table for this. And we have hydrogen, H2. So I list my elements, which is simply just hydrogen. I have two of them. They each have an atomic mass of 1.0. So that means H2 has a mass of 2.0. So 1 mole of my substance hydrogen weighs 2.0 grams. It's the molar mass. So I'm just taking the grams of my reactant, converting it to moles using the molar mass. Now I want to find out how many moles of product. I'm going to be doing what I did in the prior problem by using the molar ratio. So I'm simply going to be using a fraction bar, and I'm going to be, these grams of H2 cancel, the grams of H2 cancel. Now I have moles of H2. So I'm going to cancel my moles of H2 down in the denominator, and I want to convert into questions asking how many moles of NH3. So that's what I want, moles of NH3. How do I fill in these numbers? Well, these numbers again, going from moles to moles, if you look on the previous page, going from moles to moles is using the molar ratio. I use the coefficients in the equation. So look at the coefficients. For NH3 is going to be 2. For H2, it's going to be 3. The moles of H2 cancel, and the moles of H2 cancel. So for every 3 of these, I'll get 2 that are being produced. Okay, so that's going to end up being 2/3. So now what I do is I simply multiply the top, 5.4 times 2, and divide it by the bottom, 2.0 times 3. You can get your calculators out, and if you can actually try this and do this. Remember, you have multiple things in the denominator, so you're going to be having to use parentheses. Okay, so you have to use a parenthesis here, and then a parenthesis there on your calculator. Remember, this is the molar mass. Over here, this is the molar ratio. You can go ahead and multiply it out. You should get 1.8 moles of NH3. So that's a two-step problem. So a one-step could just be converting from grams to moles, or from moles to moles, as we did here. This used the molar ratio, this used the molar mass. But now we're going to be looking at is a three-step problem. We want to go from the grams of reactant to grams of product. This is what we did in the sodium chlorate lab. We converted from grams to moles, and moles to moles, then moles to grams. However, in our lab, this was a 1-to-1 ratio, so it really didn't affect the problem by multiplying anything by 1/1. So in this, we're going to be seeing how many grams of product can be produced. So it's a three-step. One step here, two-step here, three steps here. Going from grams to moles, we'll be using the molar mass. Going from moles to moles, using the molar ratio. From moles to grams, we'll be using, again, the molar mass. So let's take a look at this problem. We have 3.7 grams of H2. Okay. Question is, how many grams of NH3 will be produced? So grams of H2 to grams of NH3. So this is going to be three steps. 1, 2, 3. Okay, I'm going to kind of box these guys in. We have 1, 2, 3. Going from grams to moles is going to be using the molar mass. Then we're going to be going from moles to moles. That's going to be using the molar ratio. Then we're going from moles to grams. That'll be using the molar mass again. Okay, so we want to always cancel in the bottom grams of H2. So grams of H2 will go here. And I'm going from grams to moles. It's this whole theme, grams, moles, moles to grams. So it's going to be moles of H2. 1 mole of H2 weighs, we did this problem already, and it's over here, 2.0 grams. So the grams of H2 cancel, the grams of H2 cancel. Now I want to convert from my moles of reactant to my moles of product. So I'm going to cancel my moles of reactant, which is the H2, and convert to the moles of product, which is NH3. This is the molar ratio. We find the molar ratio by looking at the coefficients. How many moles of NH3 do I have? I have 2. How many moles of H2 do I have? I have 3, just like the previous problem. So this cancels the moles of H2. So I first converted from grams of H2 to moles of H2. Then I converted from moles of H2 to moles of the product NH3. Now I want to go backwards and I want to convert the moles of NH3 to grams of NH3. So the moles of NH3 converting to grams of NH3. 1 mole of NH3 weighs how many grams? This is the last step. This is the molar mass. We now need to calculate the molar mass of ammonia. So I have elements of nitrogen and hydrogen. How many N's do I have? In NH3, I have 1. How many H's do I have? I have 3. The mass of nitrogen, if you look at your periodic table or the ceiling, remember around these, the tenths is going to be 14.0. Hydrogen, the mass of hydrogen is 1.0. I multiply them across, I get 14.0, and I get 3.0. The mass of nitrogen is 14. The mass of all the hydrogens is 3. The sum of all those is 17.0. So 1 mole of NH3 weighs 17.0 grams. Once again, if you can multiply everything on the top, get your calculators out, multiply this, times this, times this, divide it by this. And again, you can either divide it in parentheses or you can divide twice, but both of these are in your denominator, so you need to watch and be careful. So after multiplying this, times this, times this, dividing by this on your calculators, you should come up with 21 grams of what? Of NH3. So to summarize, there are 3 steps to this. You can have a one-step problem going from either from grams to moles, or moles to grams, or moles to moles. If you're using either of these, it's going to be the molar mass. If you're using this middle one, it's going to be the molar ratio, as we did here. You can have a 2-step problem going from grams to moles and moles to moles, or you can start from moles to moles and go from moles to grams. Or you can have a 3-step problem which goes through all of these 3 steps. That's it, and you'll now be working on your handout in your lab, and that is going to be titled Grams, Moles, Moles to Grams.